Good morning, mathematicians. We are looking at the Wednesday column for week 26. We're starting off with the standard algorithm for adding decimals. Go ahead and add those decimal numbers and then take a look at the answer that I have listed. I have a couple students who might leave this as their answer. We want to stop and ask, what common error has taken place? Don't forget, in the standard algorithm, after you do all that work of adding your place values, you have to reflect that place value in your answer. And the way that you do it is simply bringing that decimal straight down. Since your decimal values are already aligned, your place values are easy to show by bringing that decimal straight down into your answer. Okay, let's go ahead over here and let's try out subtraction. If I have $5, I can't lose $9, right? I can't buy something that is $9. Remember, you can't switch these numbers and put a 4 here, right? Order matters in subtraction. So instead, we have to go to the 3 and we have to borrow. We're going to make this one less. Now we have one whole. To give to the 5, I'm going to give that a group of 10. 10 plus 5 is 15. So now we have 15 minus 9. That we can do, and we get a difference of 6. I have 2 minus 8. I can't do that. So I'm going to borrow from the 7. I'm going to make that a 6. And this becomes a group of 12. 12 minus 8 is 4. And then I have 6 minus 5 is 1. And 5 minus 3 is 2. Once again, do not forget to bring that decimal down and reflect that in our answer. Okay, now, boys and girls, we are looking at Woody Chip. Woody Chip is measuring his place of wood. We want to know how many centimeters are in each plank below. Okay, boys and girls, earlier this week, we took a look at the metric staircase. Many of us are picturing this metric staircase as we solve our problems. What we're thinking about in this one is converting, for instance, 43 meters, the metric measure of length, right? That base unit for length is meter, but we're going to convert it to centimeters. So to go from meters to centimeters, remember what we did earlier this week. When we go down the metric staircase, it's like for each movement down, we're multiplying by 10. So when I go 10, or excuse me, when I go 2 down to go from meter to centimeter, I'm moving my decimal 2 times to the right because that is multiplying by 100 because it's one step that's times 10. The next step, that's times 10. So again, that's what I'm thinking about. I take this number 43 and I move that decimal. It started here when it was a meter. To go to centimeter, I move it 2 times. So I have exactly 43 centimeters for my answer here. We're going to do the same thing here because we're still going from meter to centimeters. So we're going to move our decimal 2 times, and this becomes 721 centimeters. Okay, now we're asked how many millimeters are in each plank below. Notice we're going to do something very different. We're going to go from meters to millimeters. So now we're multiplying by an additional group of 10. We go from meter to deci, that's times 10, to centi, that's times 100, to milli, that's times 1,000. Because of that, we're going to take where that decimal started, which in this case was after the 6 and a whole number. The decimal sits at the end, and we're going to move it 3 times to the left. 3 movements to the left when there's nothing to move around means that we're going to plug in 3 zeros and take a look. My answer is 6,000. But it's 6,000 what? It's 6,000 millimeters. We're going to do the same thing here. We're starting with 21. We're multiplying by 1,000 because we're doing 3 movements down the metric staircase. So that becomes 21,000 millimeters. I love those powers of 10. The metric system is all based on powers of 10. That is why it works. Hopefully this also, we can see the relationship here because we're looking at some exponents and using multiplication in our exponents. Here is an example. 4 times 10 to the power of 3 becomes a 4 with 3 zeros, right? Now, in this one, what we're thinking about is, what would I have that then when I multiply by 10 to the power of 3, it becomes 6,000? Another way I could think about that is, what do I have that when I move my decimal to the right, because I'm multiplying, and I move my decimal to the right 3 times because my exponent is 3, what did I get, right? So here, if I move my decimal back to where it was before it moved 3 times to the right, I have 6. See, this 6 when I moved my decimal to the right because it was multiplying, and when I went 3 times because I was multiplying with 10 with that exponent of 3, see, it became 6,000. The same happens here, boys and girls. Really, I'm starting with 8 because I'm multiplying by 10 to the power of 3, which means going right 3 times. Okay? 9 times what gives me 9,000? Well, I know I went to the right. I can see those added zeros. How many times did I go to the right? I went 3 times. So my exponent, again, is 10 to the power of 3. Now, this time it was different. This time, instead of going 3 times to the right, I went 4 times to the right because look, I have an additional place value. So this is 10 to the power of 4. What about this one? I started with 9. I ended with 9 with 4 zeros, or 90,000. So once again, we have 10 to the power of 4. Boys and girls, what is 2 times 10 to the power of 5? Well, that would be a 2. And I would move my decimal to the right because I'm multiplying, I'm making it bigger. And I'm going to multiply it by 10 to the power of 5. And so for every movement of those 5, I'm adding a 0, 1, 0, 2, 3, 4, 5. This is my answer. 1, 2, 3, comma, 1, 2, 3, comma. Look, I have 200,000. All right, our next question. We're thinking about meters. My guy wants to make 6 mops. Now, each of those mops is going to be 75 hundredths of a meter long. How many total meters of wood does he need? He can only buy wood in 1 meter sticks. How many sticks should he buy? Okay, there's 2 different questions here. The first thing I have to do is find out what 6 times 75 hundredths is. Okay, that's the first thing that I have to figure out. I want you to pause your video and I want you to solve this with your chosen strategy. How do you like to multiply decimals? Multiply 6 times 75 hundredths and let's see if we arrive at the same number of meters. When you complete that multiplication problem, you're going to have 4 and 5/10 meters as our answer for how many meters he needs exactly to make those 6 sticks. Now, the last question tells us that, or actually the second to last says he can only buy wood in 1 meter lengths. He can't buy this ½ meter. So how many sticks should he buy? Well, he should buy 5 meter sticks. And I really should put a period after meter. He should buy 5 meter sticks because I'm going to have to get creative in my spacing here. He needs 4.5 or 4 and 5/10 meters. Boys and girls, that is a good question because we're really asking what are we doing with that remaining ½ of a meter? And because of that, we had to really add one to the quotient here. We had to make it 5 instead of making it 4 holes. right? Or 4.5. We had to make it 5 so that we would have enough for him to make the 6 sticks, or the 6 mops rather, that were asked about in this question. All right, very last one for Wednesday. We're almost there. Counting Dracula needs you to arrange the numbers from least to greatest. So we're going to make the first in our list be the very least number. Notice how I've aligned them up so that the decimal points align, and that helps me because clearly I can see, well, this one is the only one that has the thousands place. So certainly in my list, this one is going to be the greatest. That one really stands out. It's the only one that has 1,000 digits, right? Now I have two that have hundreds, but notice I have two that have the tens. Now I know that one of those is going to be the smallest and therefore first in my list. The other one's going to be the second smallest. Obviously, when I look, this 2 has a value of 20 since it's in the tens. This 6 has a value of 60 since it's in the tens. So I know this is going to be the first in my list. I know this is going to be the second in my list. And now I go to the 100 place value. This has a value of 200. This has a value of 600. So right away, that's a giveaway. This is going to be third in my list. This is going to be fourth in my list. The last thing that we have to do to finish out this column is go ahead and write them in order and simply separated with a comma because that is the way that I list these in ascending order. We want to get used to hearing that vocabulary as well. The creator of the spiral review used the wording least to greatest, but we want to remember that's also ascending order because when we ascend a staircase, we go up, right? And when we create data that ascends, it goes up in value, okay? Descending would be the opposite. Descending is like going down a staircase from the very top to the very bottom. So if we were asked to put our data in descending order, we would have had to start with the biggest one and go to the least. We have made our order match the request here for it to be least to greatest. And another way to say that, good math vocab, is ascending order.